when we want to graph the solution set for an inequality, the first thing we do is graph the related equation. So this is an inequality. Y is greater than or equal to 2x plus 1. But the related equation would be y equals 2x plus 1. So we'll start by graphing that. That has a y-intercept of 1 and a slope of 2, which is 2 over 1, which means go up 2 and 1 to the right. Up 2 and 1 to the right, and you get that line.
You're going to go like if you guys...
This we call the boundary line. So the graph of the related equation is the boundary line. Sometimes we're going to draw it as a solid line, sometimes we're going to draw it as a dotted line. This one's a solid line, and it has to do with this sign here. If this is greater than or equal to, or less than or equal to, we're going to do a solid boundary line. But if it doesn't have the equal to part underneath, so it's just greater than or less than, then we'll do a dotted boundary line. Because what we're graphing is every point that satisfies this inequality. Every point where the y value is greater than or equal to 2 times the x value plus 1. That's what we're trying to graph. If it doesn't have the equal to, then like the points that are equal are the ones that are right on the line. So we do a solid line if those points are included, and a dotted line if they're not. After we've done that, this is, like I said, a boundary line, so it means that all our solutions are either above or below that line, and we need to decide which one. So is all of this over here the solution set, or is all of this over here the solution set? And the way we're going to decide is by testing a point that's in one of those regions, either of those regions. If I can, I usually test this point, 0, 0, because it's easy. The only time I won't test 0, 0 is if my boundary line goes through 0, 0. So I'm going to choose a point to test. I'm going to test 0, 0. And so I'm just going to take that original inequality and I'm going to replace both the x and y with 0. And then simplify. 2 times 0 is 0, plus 1 is 1. And I end up with this. 0 is greater than or equal to 1. Is that a true statement or a false statement? False? 0 is not greater than 1, right? 0 is less than 1. So that's a false statement, which means that 0, 0 is not a part of the solution set. If 0, 0 is not a part of the solution set, then nothing else in that region is a part of the solution set either. And the solution set is over here, above the line. So what we do to show that is shade it in. And what that shading means is that any point in that shaded region satisfies this inequality. So if we take a point like -5, 0, we fill 0 in for y and -5 in for x, we get a true statement. If we take another point like -2, 3, same thing, fill it in, you'll get a true statement. If you take anything that's outside of the shaded region, you'll get a false statement when you fill it in there. This is the solution set. Here's another one. Graph the solution set. You can kind of see it down there in the corner. But first thing we have to do, get y by itself, right? Because we can't graph it when it's in that form. So we will isolate the y. I'm going to subtract 3x. So I have 2y is less than -2x minus 3. And then divide by 2. Yeah. So we'll have y is less than -x minus 3 over 2. Yeah. And then the related equation is just y equals -x minus 3 over 2. which is here, that's what it looks like, has a y-intercept of -3/2, -1.5, and a slope of -1. So over 1, up 1, over 1, up 1, it's -1, so we're going to the left. Or you could look at it as down 1, to the right 1, down and to the right. But it should slant that way towards the left if it's negative. Do you notice that this one is a dotted line? Can you see that from where you are? This is a dotted boundary line. And the reason is? It's not equal to, right. So the solution set does not actually include the points that are right on that line. On your graphing calculator, you're not going to be able to do a dotted boundary line and a greater than or less than. So you kind of have to choose one or the other. So you basically are going to have to remember to do a dotted line for this type and a solid line for the others. If I want to test a point to see where to shade, I'll test 0, 0. I like to test in the original equation unless it's like a ton more work. To test 0, 0, 2 times 0 plus 3 times 0, so that's 0. And then, I'm testing 0, 0. And then 0 minus 3, so -3. 0 is less than -3. Is that true or false? That's false. So I'm not going to shade over here where 0, 0 is. I'm going to shade on this side, away from 0, 0. If this comes to a true statement, then I will shade 0, 0. If it comes to a false statement, I won't. So when you do the shading, this is what it looks like. Away from 0, 0. Let's see. So if I were to ask, what are some ordered pairs that satisfy that inequality? Could you come up with one? What would one of them be? So an ordered pair that satisfies that inequality. -5, 2. Right there? Ish? Yeah, that satisfies the inequality. -5, 2. What's another one? -15, -5. Yep. Another one?
So if it's in the purple, it's good.
If it's in the purple, it's good, right. So what if I ask you this? Does the ordered pair 0, 5 satisfy the inequality?
No.
Nope, it's over here. Does the ordered pair -10, 5 satisfy the inequality? Yeah, it's over here. Does the ordered pair, let's see.
-4.
0 and -1.5. Does that satisfy the inequality?
Yeah.
0 and -1.5.
Yeah.
Oh, we've got a yes and a no.
Wait, no.
And John Ray is adamant about no.
I see.
Why?
Wait, what's the order period?
1 point.
0 and -1.5.
I say yes.
Oh, it's not exactly straight.
I say yes.
You're right.
That'd be like what?
No.
John Ray's right. It's no. Why is it no?
Because it's not equal to.
Right. It's right on the boundary line. It's right there. And if it's a dotted boundary line, then those points are not included. Because there's no equal to. If you fill that point in to the inequality, you'd get 0 is less than 0. And that's not true. So that one does not work. Here's another one. What's different about this one?
It gives you the y.
It's quadratic. Right. So we don't have to isolate the y. It's already isolated. I'm not going to get into graphing this manually. You could by completing the square and putting it in vertex form, which you may need to do for your exam because we did do that this semester. But right now we're just going to look at, if we use our calculator and graph that, here's what we end up with. Should I have a solid or a dotted boundary line? Solid, and that's what we have there. Because of that equal to, right? This is greater than or equal to. And so for one like this, quadratic, we're either shading inside or all of the outside. And so if we, oops, oh, did you see that? If we test, again, 0, 0, because it doesn't go through 0, 0, which makes it easy. 0 is greater than or equal to -3. Is that true?
Yeah.
Yes, that means we shade where 0, 0 is.
How do you do that on the calculator?
And 0, 0 is right there. So we shade in there. Here's the last one. Write an inequality to describe the following graph. So first we're going to write an equation just for the boundary line. So we're going to do y equals ax minus p squared plus q, vertex form for a quadratic function. I'm going to fill in one of the points that I know as x and y, and then the vertex as p and q. So let's do 0 for y. I'll use this point here, 0, 1. I don't know a. X is 1 minus 3 squared plus 2. 3, 2, that's the vertex, so that's the p, those are the p and q values. And then if I simplify this, 1 minus 3, that's -2 squared. I'm going to move that 2 over, so it's -2 equals, and then -2 squared is 4, so 4a. Divide by 4 and we get a equals -2 over 4, or -1/2. So then we have the equation of that boundary line is y equals -1/2 x minus 3 squared plus 2. But I don't want an equal sign in there, right? I need to figure out, do I want a greater than or a less than sign? It's a dotted line, so I know I don't want greater than or equal to or less than or equal to, just greater than or less than, but I have to decide which one. So there are a few different ways that you could find out. If you want to do it algebraically, test a point. So again, 0, 0, I'm going to fill it into this equation. So we'll go, let's see, all right. 0 equals -1/2 times 0 minus 3 squared plus 2. And then that comes out to -2.5, and I need to decide what symbol should go in here. Is it a greater than or less than? Is 0 greater than -2.5 or less than -2.5? And it's greater than, so I'll put a greater than symbol in here. Your other option is you have a graphing calculator, so just graph greater than, see if it looks like this. If it doesn't, graph less than, and see if it looks like that. One or the other is going to look like that, so it's pretty easy to figure out which one with the graphing calculator.